2018, question 3. Question 1 was probability. Question 2, probability stats with a normal distribution curve. So 75 marks for question 3. A nice easy start to this year's paper. A security code consists of 6 digits to be chosen at random from the digits 0 to 9. Now normally these can't start with 0. This one, it may begin with 0. It may begin with 0 and the digits may be repeated. For example, here you can see we're starting with a 0 and 7 is repeated 3 times. How many codes end with a 0? So we have 6 spots or 6 sample spaces where we can put probabilities in. We're going to multiply them all. So how many end with 0? So if it has to end with 0, we have a 0 in here. And I'll write the probabilities underneath. So that's a certainty, that's a 1. So with the digits 0 to 9, how many options do we have here? We have 10 options. We have 10 options. We have 10 options. 10 options, 10 options, and we have 1 option at the end. So that has to happen. So the answer here is 10. And we have 10 to the power of 5. 1, 2, 3, 4, 5. That's 100,000 different options. How many codes will contain the digits 2018 together in this order? Okay, so if we look at our 1, 2, 3, 4, 5, 6 spaces, how many of them can possibly contain 2018 in that order? So we start here, 2018, we're going to end up in the 4th box. If we start in the 2nd box, you see we're going to end up in the 5th box. And if we start in the 3rd box, 1, 2, 3, 4, we're going to end up in the 6th box. So there's 3 spots to put 2018. So they have to be together. So if 2018, let's just say they're in 2018. So what's going on in the other 2 boxes? Well, we have, they told us we can have any amount of options. So we have 10, we can put 10 in here, and we can put 10 in here. So these can't change. This is a 2, a 0, a 1, and an 8. So we just have 10 by 10 by 4 ones. So we have 10 by 10. And we can see that that happens in 3 different spaces where these dots start and finish. So we have 100 by 3. In this case, is 300. And the next part of this question, which is the last part, actually quite short questions. A, B, C, D, if n plus 3 factorial, n plus 2 factorial over n plus 1, n plus 1 factorial is equal to this cubic. So we just need to understand what factorials are and multiply them out. So n plus 3 is n plus 3 by n plus 2 by n plus 1 all the way back, keeps on going. And we're multiplying that by n plus 2 by n plus 1. And that's going to keep going. And that's over these 2 n plus 1 factorials, which are going to cancel with whatever's happening from here all the way back here. These 2 n plus 1 factorials on the bottom. And I just left out the factorial to make it just a bit neater. So we can see here we're going to be left with n plus 3 by n plus 2 by n plus 2, which we just have to multiply out to get a cubic. So really straightforward, juniors there at maths. N squared plus 3n plus 2n plus 5n plus 6 by n plus 2. I prefer to have it in front. So I'm going to get n cubed plus 5n squared plus 6n. And lining up my like terms underneath, I'm going to get plus 2n squared plus 10n plus 12 to give me n cubed plus 7n squared plus 16n plus 12. So A is equal to 1, B is equal to 7, C is equal to 16, D is equal to 12.